So this is a hard question, and we're told that a certain amount of change is given, and we're told that it's in exactly 4 coins, and these could be duplicates. And I'm going to use cents to write the values. So 1 cent, 5 cents, 10 cents, and 25 cents. So it could be 2 of those and 2 of those, but it has to be an exact 4 coins. And the question is, what's the value? So I'll start with statement 1. Says one of the coins is 1 cent out of the 4. So I always like to put some examples just to kind of make sure that we have different values. This one is easy enough. You could say they all were 1 cent. In this case, this is how much the total value of the change is. Then it could be just 16 cents. So we have 2 distinct values. Statement 1 alone is insufficient. 2 says that the correct change could have consisted of exactly 2 coins. So we're already told that the change does consist of 4 coins, but it could have also been made with exactly 2 coins. So I have to come up with examples, and this is the hard part for the statement 2, because it's kind of not clear whether that's the case or not. So this is where you would need to do a little bit of trial and error. So I know that bringing in 1 would be difficult because you'll get some odd numbers. So I'm going to just focus on 5s, 10s, and 25. So 2 of those I'm going to pick, let's say 25 and let's say 5. So that's 30 cents. And then I need to make 30 cents with 4 coins. So that would be 10, 10, 5, and 5, because I need to satisfy the information given in the main stem. So in this case, the value is 30 cents. Another case could be 25 and 10. That's 35 cents. That would be 10, 10, 10, and 5. So I, again, satisfy what's given in the main stem, and I have the same value with 2 coins. And you will see we have 2 different outcomes. So 2 alone is insufficient. And actually, I mean, just want to comment that it's not easy to come up with these examples under time and pressure with the same numbers floating around. It can be kind of mentally confusing. That's just part of the game. So 2 alone is insufficient. Now 1 and 2 is also hard. They say one of the coins needs to be 1 cent. And then we also need to be able to get to the same change with 2 coins. So the key thing here is the possibilities with 1 cent are if you have just one of them is 1 cent, 2 of them are 1 cent, 3 of them, and then 4. Well, we know the 4 case is not going to work because there's no way I can have 2 coins that add up to 4 cents. This will also not work because if this is 5, then it's 8. I can't get to that with 2 coins. 10, 13 also I can't get to with 2 coins because if you have 13, 5 and 10 would give you 15. So that's also not possible. And this one with the 2 coins, with 2 are 1 cent. If there are 5 and 5, that's 12. I won't be able to get to 2 coins because it would be 10 and 1 and 1. So you'll notice that if you try a different example, that's also not going to work. What this really means is that one of these 2 coins has to be a 1 cent coin, or maybe you would have seen that immediately here. So that's the key thing is out of these 2 coins, one has to be 1 cent. So my possibilities are 1 and 5, 1 and 10, and 1 and 25. And then I have to see if it adds up to 6, can I get to 6 with 4 coins? And you'll see that you can't really. 1 and 5 would be 6. And then, you know, if you do 1 and 1, you already exceed that. 1 and 10 is 11. Can I get to that with 5 coins? 1, 5, 5, 1, no. So we're really left with just that case, 26. Can I get to 26? So 1, 5, and 1 is 6. Then 10 and 10, and yes, I can. And that will be the only case, which means that if you combine 1 and 2, this is the only way you can give out the change for 4 coins. That's 26 cents. And that can also be split using 2 of those coins, which is one is 1 cent, other is 25 cents. So 1 and 2 together are sufficient. The answer is C. So yeah, it's a hard question, partly because you have to consider all these cases, and doing it under time and pressure is always difficult. So the answer here is C.